What's up, math scholars? It's Tuesday, and we are going to go over these accelerated add-on problems. So there's only 3 of them. This video will go quick. Who's excited? Woo-hoo! Henry doesn't look excited. All right, we're finding all theta. So there's probably going to be 2 thetas for which cosine theta is -3/8. So I always recommend the sketch on these, and I always recommend putting a star in the quadrants where cosine is negative. What quadrants have negative cosines? Here, quadrant 2, and where else? No, quadrant 3. Sine is negative over here, but cosine is positive over here. So I know before I even start, that's where my 2 angles are going to live. What you're going to do is a cosine inverse in your calculator. Are all you guys still in degree mode? You didn't switch to radian? If you start watching the chapter 10 and puzzles, you'll be switching your mode.
I'm tired to know.
Cosine inverse -3/8 puts me at 112. And that is in the quadrant I want to be in. Yay! Now, what I'm going to do is use a reference angle to flip me down into quadrant 3. How big is this reference angle right here going to be if this is 180 degrees? 68. So I'll use a 68-degree reference angle here, and I'll do 180 plus 68 to find the other place that this would work. What's 180 plus 68? Yep. So your 2 answers for number 18 are 248 and 112. All right. Are we good on 18?
Sure.
Can't wait to do my gardening problem. I literally picked this out because it made me think of myself, gardening and fertilizer. It's that season. We're planting sweet corn right now at the farm, if you're wondering. All right. Woo. So you're fertilizing a triangular garden. One side of the garden is 62 feet long. Another side of the garden is 54 feet long. And the angle opposite the 62 is 58, so it's going to be down here. Part A, draw the diagram. Done. Part B, solve the triangle. So we're going to use law of sines to solve this triangle. I already solved it, and we're kind of lucky that there's only one possible triangle. Because you know how with the law of sines, you always have to check if the supplement would work? The supplement doesn't work on this one. So this is my work for part B. I partnered up the 58 with the 62. And now I'm going to partner up, I'll just call this angle A. I'm going to partner up angle A at the top there with the 54. All right, does everybody remember crisscross applesauce in the steps? Cross multiply the 54 times the sine 58, divide by 62, and then do a sine inverse at the very end, and tell me what you get. 54 times sine. You did so much math yesterday, the calculator died.
No, the calculator was just slowly losing.
I got 47.6. Is that what you guys got?
Yep.
Now, I always like to tell... Oh, did I mess up?
I think I messed up. I don't want to get it wrong.
All right, I'm picking my answer team. It's okay. Try it one more time. I do want to consider the supplement because that's what I taught you guys to always do. Consider the supplement just to see why it doesn't work. It doesn't work. And the reason it doesn't work is it's 132.39. And 132 partnered with a 58 is well over 180. So it's just too big.
Oh.
Well, I mean, you can pretty much do that in your head. If the angle you get is smaller than the angle that you're starting with, that you used for the first time, it's going to be, you'll be able to use the supplement.
I was more thinking if these two add up to over 90, then the supplement.
I mean, that would also work. It does add up to over 90, or if the one you just found is smaller than the one you were using.
Okay. I guess so.
I don't know what I'm doing wrong.
Oh, well, let me just... Are you in the wrong mode?
No.
Finishing off this triangle will be easy. We'll do 180 minus the 58 minus the 47.6, and that'll be our remaining angle. Do you guys have 74.4? I have. And then we'll do one last quick law of sines. Why can I not use the Pythagorean Theorem? I always get bored buddies up here, and they love the Pythagorean Theorem, but this is a non-right triangle, so it doesn't work. That's sine 74.4 over, we'll just call this side small c, how about that? crisscross applesauce. 62 times sine 74.4. My computer's going crazy on Google Meet. I don't know what's going on over there. Divided by sine 58. How does 70.4 sound? Alright, we're not done with the problem. That was only part B. We have to talk fertilizer. Extend my page a little bit. So what we have to do is apply fertilizer. 1 bag of fertilizer covers an area of 200 square feet. We better find the area of this garden. We really have the option to use this area formula up here, the side angle side, or the side. I like the side angle side formula, so I'll just write that down for the kids watching the video. 1/2 BC sine A, where the angle A is the included angle. So I'll just circle the ones I'm going to use. You can use whatever ones you want. I'll just use this side with this included angle.
And so does that mean that you can, in theory,
You could have done this.
if you know 2 sides in the area?
If you know, we're back. You're going to do the 62 and the 54 and do the sine of 74.4. But like I said, that was not your only option. You could have used the 54 and the 70.4, and the included angle would have been the 58. So you really can do whatever. You should get the same answer either way. 1/2 times 62 times 54 times sine 74.4. Did you get your area to be 1612.33? I must not have written that down. Oh yeah, I did write that on my paper. 1612.33. So the area is 1612.33 feet squared. We're going to divide by 200 because each bag covers 200 square feet. Let's see how many bags we need. We need 8.06 bags, so I better buy 9 bags of fertilizer because 8 won't be enough. So you have to round up to 9 bags. Hey, did any group get that yesterday when you were working together? All right, we're on the swimming problem, and you're looking at an object under the water. I don't know if you've ever done this before, but if you look at an object in the water, it's gonna look further away than it actually is because the water's kind of bending the light a little bit. The physics teachers could probably explain this better than me. But basically, we're gonna have theta 1, and it's gonna be 70 degrees. We're gonna need to figure out what theta 2 is. Now, there's a little bit of information we need right about here. The index of refraction for water is 1.3, and that's the ratio of the sine of theta 1 to the sine of theta 2. So the sine of theta 1 to the sine of theta 2 is going to be 1.3. 3. Oh, I think I missed a 3 when I did this on my paper. That's probably why my answers were slightly off the book. This time I'll do it the right way. So, we're going to put theta 1, 70 degrees, in the top of this ratio. And we're going to solve it for theta 2. I meant to put a 70 right there. I forgot. Oop. Okay, so do we know how to solve this? I would multiply the sine theta 2 to this side and divide the 1.3 to this side. So basically, I'll have sine theta 2 equals sine 70 over 1.333. So sine 70 divided by 1.333 is a small decimal, 0.7049. And then I'll just use the sine inverse, and I'll have my theta 2. So sine inverse both sides. I got theta 2 to be 44.83 degrees. Any problems with that part? 44.95. Yeah, I was slightly off on my paper, but I was missing a 3. So 44.83 degrees. And I can label that. All right, what's up next? Find the distance x and y. You can use tangent to find both of those. If I'm finding x, I'm going to use tangent of the 44.83 and just do opposite over adjacent, x over 4. So tangent of 44.83 is x over 4. Multiply both sides by 4, and you have it. 3.78. Oh, sorry, 3.98. I can't read off my calculator screen. And is this in feet? Yeah, it's in feet. So any trouble using tangent? All right, we also have to solve for y. I'm going to do this big triangle here. You remember geometry, right? Geometry, I can use these things called vertical angles. And if this is 70 degrees, this is going to be 70 degrees right there, that big line, the whole entire angle. So I just did tangent of 70 degrees is y over 4. Multiply both sides by 4, and that's going to be y. 10.99999. Maybe I should just round it to 11. I'll round it to 11. Part C, we get to get D, the distance between where the goggles are and where they appear to be. If you look closely at the diagram, to figure out D, you can just do y minus x. So D is just the distance y minus the distance x. .02. And then I'll see if you guys have the answer to this. As that guy walks closer to the goggles, what's going to happen to distance D? Which is the difference of where the goggles are, where they appear to be. Any idea? It's going to actually decrease. So the closer he gets, they're going to actually appear to be closer to where they actually are, because when he gets really close, they're going to appear exactly where they are. So it will get smaller. Thanks for watching the video, everybody at home. Test Thursday.